team, here's a quick look at some new features I've been adding to the schematic. First of all, a simple one. Sometimes when you are analysing a circuit, it can be helpful to have a resistor create no noise. You might want to do some kind of signal processing without having the resistor noise, so you can analyse where noise is coming from. Previously, we've had a special resistor, namely this one, which when it was switched to the macro model type, when it was switched to the macro model, it would create no noise. I thought that was a little bit inconvenient, so now I've added a generic feature to all nominal resistors. You can turn the noise off. You can do it with the N button. That resistor will now generate no noise. Its name goes red, just to remind you that that is the case. That gesture is here, N toggle resistor noise. So that's the first little feature I've added. Regular resistors, not semiconductor resistors, but regular resistors, you can toggle the noise on and off. I'll show you how that's working. It's very simple. It's simply in the net list here. In the net list, that's the regular resistor there. If I turn on that flag again, it simply writes noise equals 0 at the end of the line. Simple as that. Okay, let's have a look at something else now, which is a lot more useful. A lot of what I do is a search for elegance, meaning I like to be able to look at a schematic and understand what's going on. So this thing here, this is a model I use, which is an amplifier. It has a certain clipped gain, meaning it won't exceed 400 millivolts output. It has a gain, let's put that gain at like 1k, 1000, gain of 1000. It has a noise per root hertz of 1.44 nanos and a few other parameters associated with it. And I use this to build models of things. So for example, there might be a number of these guys in a chain. You can see that the default number of that was 4. There might be a number of these in a chain that I'm using to, I don't know, maybe, I put some capacitance on there to limit that guy to some output speed because it's got a finite output impedance. Let's say that output impedance is 150 ohms, and there we go. So there's a whole bunch of these in a circuit, and I'm kind of modeling something helpful. I don't know what that might be in this case, but I'm just showing an example. Now what irritates me a little bit is that there's far too much text on this schematic. I'm losing track of what's going on underneath because of all those different parameters. So I've just added this feature. You can move over here and click use parameters here, add use parameters. I'm going to do it with the U key, just a little bit quicker, U. I've added this ability. You can link the parameters of this U2 to another use at this level, and it chooses the first one. You can change it to whichever one you want. So I'm going to say link U2 parameters to U1 parameters. Well, isn't that much better? Now we know that all of those guys are the same as that. We don't need to repeat the text when it's the same. Now the first question you're going to ask is, well, how do I know what's going on? Well, in common with every other feature, if you hit the numbers lock key on the keyboard when the mouse is over the background, it will show you all the actual math, so to speak, that's going on. And we can see that this clip is being got from at U1 clip. So that clip value is the same as U1 clip value. If I do that again, like that. Well, again, I think that's an improvement. That's helpful. Here's another slight improvement as well. I'm just going to take this guy out and put him, for instance, up here, just floating around in space up here. And I'm going to rename this one to, well, let's rename this one first to U1, because these are all referring to U1. And this guy had his name locked, by the way. He had his name locked so that you couldn't change it to U something else and lose track. It doesn't matter. Let's get rid of that one. Everything's good. It's referring to U1 there. I'll put another one in here, like so. And I'll rename them, make it look a little bit more beautiful. U1, U2, U3. And notice that this thing then can sit up in the top of the corner of the schematic, and it can define all the parameters, and all of them are inheriting from U1. And as long as U1 is left with all its non-optional ports unconnected, it won't be a problem. So what I mean by that is that even though that guy has no connections, it doesn't matter, because as we can see here, it will say U1 noise clip gain is not net listed because all its ports are unconnected. Okay, so to summarize then, I've added two new features recently. The first one is this ability to define parameters from another instance, and the ability of that instance, or any instance indeed, to be in the drawing, and if all of its non-optional ports are unconnected, it won't be net listed. So that rather messy drawing turns into this, much nicer one here, where we don't have all that text confusing what we're doing, but we know that all these guys are the same. I hope that helps. It certainly helps me.